Exercise 522 is going to allow us to practice a little more with math functions. Okay, and we are going to pretty much build an algorithm. Well, the algorithm is given to us from the textbook, but we are going to build a program that's approximating a square root. So let's start by the main. Okay, what we are going to do in our main. Well, we are going to validate our program by doing a system.out.println of our approximation, followed by the real thing as computed by the sqrt method of the class math. So let's get started with square root of 9 is. We display this message on the screen. We go to the next slide. And then we're going to display println. I'm going to put a tabulation here. Tabulation, and we are going to display the first result, the real result, math.sqrt of the value 9.0. So this is computing the square root using the math class. Okay, and then we are going to typo here. We are going to display on the next line a tabulation followed by our own approximation. So we are going to call this function, this method sqrt as well. It's from our current class. Okay, so sqrt of 9.0 will display the result returned by our own method. So next step is of course public static double. This is going to be the return value of our own version of square root, and square root is going to take as parameter a double n, which is the number of which we want to approximate the square root. Okay. At that point, we can refer to the algorithm that was given to us. What we need to do is we need to keep refining a guess. Okay. So we are going to have two variables. Next guess, which we initialize to 1, and another double, which is going to be the last guess we made, which is actually initialized to nothing here, and we are going to initialize it in our loop. So proceeding by successive refinement means that we need a loop. Okay. First thing we are going to do in our loop is assuming that our last guess is value of next guess. That's why I assigned next guess to 1 and not last guess in the initialization, contrary to what is indicated in the textbook. Now the next guess is where the magic will lie. We are going to take our last guess. We are going to sum our last guess with divided the number divided by the value of last guess. So let's say that our last guess was 2 and that we are trying to approximate the square root of 9. The real result should be 3. Well, what we do is we take 2, we add 2 to 9 divided by 2, which is 4.5, and we are going to do the average of this. So we try to move toward what should be the real value of the square root by averaging the current guess with the expected value of our next guess. Semicolon. Our condition, we keep doing this while the absolute value of the difference between the next and the last guess is greater than an arbitrarily small number. So how do we compute an absolute value? Math.abs, absolute, next guess minus last guess, and we are going to say that this has to be greater than 0.00001, arbitrary precision. Once we are done, return next guess, and we are done. So let's save this file, move to Conqueror. We are going to javac this file 522. Oops, 522.java. We do a lot better. Semicolon missing line 16. Line 16, there we go. Check our parentheses. There is an extra parenthesis here. Again, save. And we're going to wait for the modified to go away here. Little delay. Okay, there we go. Our file is saved. javac again. Oops, I went too fast. System.println, of course, is going to be a problem. So we have this at line 5 and 6. 5 and 6 print ln is fixed. Save. Once the modified status goes away, I go back to my Conqueror window, compile again. Java E522. Square root of 9 is 3 and 3, given our approximation and the correct algorithm implemented in the math library. So here's the code, and you can test it on different value, of course, to make sure it's working. But we are done with this exercise 5 to 2.